Hello, this is our River Project presentation, and we are the RiverBoys. I'm Alex Ferreira.
I'm Noah Weston.
I'm Blake Davis.
And I'm Steven Arnsberg.
Our goal for this project was to create a fish passageway to accommodate the wolfpack fish, allowing them to swim through rivers, streams, weirs, etc., avoiding potential obstacles in and along the waterway. We put in research to find ways for our fish passage to avoid high-speed velocities, as well as non-habitual features that may steer the fish away from the design. Two of the main components of their natural habitat are ripples and pools, so we wanted to find a way to include both of these elements in our design while also controlling the velocity and making it as natural as possible. After researching existing fishways, we found two examples that we took our primary inspiration from. The image on the left shows a tiered pool system, which we really like the idea of because it provides staggered descending pools, ripples from the falling water, as well as the ability to control the downhill velocity. The image on the right shows our inspiration for the V-shaped deflectors that we included throughout the passage. They contribute to the ripple effect, reducing the water velocity and allow for the fish to travel in a non-straight path, which contributes to the fish's comfortability traveling through the stream.
Here in our initial sketch, we have the concave circles and also the V deflectors. We combine that into one design. On the side view, we have a step system, which would create necessary swimming depths for the wolfpack fish. And we also came up with an idea for a flap gate, which would assist in the velocity of the water and keep debris out. In our initial design that we designed on SolidWorks, we have the tiered pool system, we have the V deflectors. We also changed the idea of the flap gate to small openings, which would allow the wolfpack fish to travel through, but also keep debris out. We also had a goal of creating a natural environment for the wolfpack fish, which would mimic the natural habitat of the fish with plants and rocks to create riffles. But we were unable to do that since we were on Fusion and SolidWorks.
For the second design, we corrected the dimensions to fit the project specifications. We deepened the pools to further slow the velocity and allow for more water flow. We varied the deflector sizes, the first two ones catching the water, and the second set pushing to the sides in the next set of deflectors. We also temporarily removed the gates while we changed their look. For the third and final design, we polished off our design. We added a flap gate that only allows water flow one direction. We added some beams for support. And again, we were not able to add the natural environment because we were unable to do the physical model.
All right, after finishing our design, we began testing our creation using a fluid dynamics simulator. In the left photo, the velocity starts flowing from left to right at a flow velocity of 0.1. When we move to the right photo, we see the lighter colored areas, which represent higher flow velocities, and the darker areas, which represent lower flow velocities. Analyzing this information, our system diverts the higher flow velocities to the sides, which limits the velocities where our fish will actually be swimming. And then after our simulation was running for a while, we recorded velocities of the system. You can see this in the circled column. Velocities hover around 0.02, which demonstrates how our system reduces flow velocity as the water flows throughout the entire system.
We ran into some challenges in our testing, creating, and planning. In our testing, the animation and testing the velocity flow of the water was hard to do. We could not do it in person since we did not build the actual model, so we had to use a third-party fluid dynamics simulator to test the water flow. In creating the model, once again, we were unable to physically create it, so we had to build it in Fusion 360, and it was hard to mimic the natural habitat on Fusion. In planning, we were unable to meet in person, and virtual teamwork was harder than working in person.
All right, if we had to do the project over again, we would spend more time designing and testing our product. We also said that we would create a solid model to be able to work with in person. And lastly, we said that we would experiment with multiple different design ideas to see which one may work better than the others.
For new students, don't procrastinate. Set team member roles early. Weekly meetings are definitely important. And preparing ideas and work outside of team meetings is also very important.
These are our citations. This has been our River Project presentation. Thank you for your time.